Hi everyone, Mr. Rodriguez here with another video for you all. Today we are going to be talking about recognizing equations of circles. So if you remember from last lecture, day 16, we talked about equations of circles and how to write them, and how to determine radius and the center point. If you did not do that lesson yet, you really need to do that lesson before you can do this one. This lesson won't make much sense to you if you haven't done day 16. So I do suggest, highly suggest doing that one before this one. Okay, and our specific objective for today is students will be able to complete the square. So this is a specific kind of tool that we'll be talking about. So students will be able to complete the square in order to write the equation of a circle in center radius form. Just to kind of refresh, center radius form was this form where you had x minus x1 plus y minus y1 equals radius squared. And again, our x1, y1 point is the center, right? The center point, and our r is our radius, right? So before we get into that, we want to do some kind of warm-up review exercises. These topics will be helpful for you in tackling this lesson. So for our first little opening exercise here, we have to express this as a trinomial. So remember, a trinomial is an expression with three terms, kind of like this would be an example of one, right? We say we have 1, 2, 3 terms. So to do this, we have to use something called, well, first let me say, x minus 5 squared, that would be the same as x minus 5 times x minus 5, right? Because it's just x minus 5 times itself. That's what the square means. And to express this as a trinomial now, we need to multiply these two binomials together. And we do that using something called FOIL. This should be review. You should hopefully remember this from previous grades. If not, I'll go over a few examples here, but you might also want to, use YouTube, Google, kind of type in how to use FOIL method or something like that. There'll be a little extra review if you need. So in FOIL, the F stands for first, so that means the first two terms. I could use a different color. So x times x, that would be x squared, right? The O here, that stands for outer. So that would be the outermost two terms, the one all the way on the left and the one all the way on the right. So x times minus 5, that would be minus 5x, right? You could just write that as minus, right, 5x. And then, let's say we use a different color again. The I stands for inner, so it's the inner two ones. Again, a negative 5 and an x. So we have minus 5x. And then lastly, the L stands for last. So we have the last two terms, the negative 5 and the other negative 5. Negative 5 times negative 5 is positive 25. So now we have four terms here, but again, we want this as a trinomial, right? 3. So you'll notice that we can actually combine these two terms, right? They're like terms. So we would have x squared minus negative 5x minus 5x would be negative 10x, like that, and plus 25. So this is our answer here, right? This is a trinomial since we have 1, 2, 3, right, kind of terms, right? Okay, let's look at another example. It's very similar. So express this as a trinomial here, x plus 4 squared. So again, this is the same thing as x plus 4 times x plus 4. And again, we can just use our FOIL method. So first we have the two x's, right? So that would be, oops, oh, what happened there? So that would be x squared, right? And then we have the O, which is the outer ones, right? So x times 4, that would be positive 4x. Then we have the I, the inner ones here. Again, positive 4x. And then lastly, we have the outer ones, right? So that would be, I'm sorry, that was, I meant the, getting confused here. I meant the last one is the last ones, right? So we have, right, the 4 and the 4, which would be positive 16. So again, we can combine these two terms in the middle. So we get x squared plus 8x plus 16. And that's our answer. Next problem here is to factor the trinomial. So now we're basically going to go reverse method. So before we were given this kind of simplest form, right, like up here, and we turned it into a trinomial. But this time we're going to be going the other way around. So we basically know it's going to look something like this, right? We just have to figure out what number goes there and what number goes there, right? Is it going to be like, you know, plus 4 over here and minus 6 over there, or, you know, some kind of number just like we had up here. They don't necessarily have to be the same number. That was just kind of a special case up here. So the way we solve this basically to get the two numbers is we're looking for two numbers that, so we want to look for two numbers that add to 12 and multiply to 36, right? So number 1 and number 2, they have to add to 12, and number 1 and number 2 have to multiply to 36. The best way to solve this kind of problem is to actually just think about what are all the factors of 36. What are all the two numbers that you could multiply together to get 36? So we have, for instance, we have 1 and 36. That doesn't help us, right? They don't add to 12. We have 2 and 18. Again, does not add to 12. We have 3 and 12. Okay, well, we have a 12 there, but that doesn't add to 12, right? That would add to 15. We have 4 and 9. Getting closer, that adds to 13. 5 is not a factor of 36, right? So we could skip that. Then we have 6 and 6. Well, here we have bingo, right? Because 6 plus 6, that adds to 12. And again, they multiply to 36. So and since we have positive 6 and positive 6, we just write it like this. Plus 6, plus 6. The only time this kind of thing can get tricky is, you know, sometimes you might have like a negative number you have to deal with. So then you kind of think about, you know, if you start making some of these negatives or positive, these factors and how they add up. Again, I would just recommend looking up maybe more examples online, since that's not the focus of this lesson here, if you need more review with that. But back over here, so we have x plus 6 times x plus 6. And again, you'll notice it's just x plus 6 times itself. So we can write that as x plus 6 squared. Okay, so that's some basic review. Now for the most, or one of the important parts of this lesson, is we're actually going to talk about what completing the square is. So completing the square is basically a method you can use to help you factor when, for whatever reason, it's too hard to kind of just do it in your head like we did in C. Like for C over here, basically just kind of did it in our head, or we just kind of wrote it down and thought about it. But for whatever reason, that's not always the case. It's not always that simple. But completing the square, this method I'm going to show you, basically gives you a foolproof way to factor it, kind of like regardless of what it looks like. So let's see here. So we have this equation. So the first thing we basically notice is that this is not a trinomial, right? This is just a binomial. So the way we can use completing the square is it's basically you're going to take this second number here. So you see how that's like number 2. If you remembered from the most general form is a squared plus b squared, plus, so what am I doing here? I am messing this up. Remember, the general form is ax squared plus bx plus c. That's kind of like your standard trinomial equation there. So this second number here is always called b, basically. And all you need to do is you need to first figure out, this is just, I'm not going to get into why this is true. Again, this is something you could just, this is review. If you need more help with it, I would recommend just putting in YouTube or Google how to complete the square. But basically what you do is you just do b divided by 2 squared. So again, here our b is 6, right? Our second number, it's always going to be, our b is always going to be this second number there. So 6 over 2 squared, which is the same thing as 3 squared, which is 9, right? And okay, now what do you do with this number, right? Basically what you're going to do with this number here is you are going to add it to both sides. So what you're going to do is you're going to change this from x squared plus 6x. You're going to add 9 here. And whatever you do to one side, you have to do to the other side, right? So that 40, you're going to add 9 there also, right? That's going to become 49. And now what you'll notice is that now we have a trinomial here that we can play with. So we can factor this now. It's a little easier, right? So now we just think about what number multiplies to 9 and adds to 6. If you think about it for a little bit, you'll realize that it's 3, right? So now we have this x plus 3 times x plus 3 equals 49. But again, we're actually trying to solve the equation. So we're actually trying to get values for x. So what we can do here is, again, x plus 3 times x plus 3 is x plus 3 squared equals 49. And what you can do now is you could take the square root of both sides. Remember, the square cancels out with the square root. So you're left with x plus 3. And then the square root of 49. Well, this could be 7 or it could be negative 7, right? So we kind of say it could be plus or minus 7, right? Because both of those would get you to 49. And then what you can do is you can, first you take x plus 3 equals, let's say, positive 7. Then you can do x plus 3 equals negative 7. Again, if this looks totally kind of weird to you, I suggest using Khan Academy, YouTube, Google to kind of review this, since this is from previous math classes. And you just solve for x on each side. So over here we get x equals 4. And over here we get x equals negative 10. Oops. So this is supposed to be 4. So we have 4 and negative 10. Okay. And so let's look at one more problem. So now we're going to get a little more into the crux of the lesson, which is if this equation, so our problem is it says the following is the equation of a circle. So it's saying that this here is actually the equation of a circle with radius 5 and center 1, 2. So it's telling you that, but we just want to figure out how do we know this is true. Right, now this looks nothing like the equation for a circle. Right, remember the equation for a circle is x minus x1 squared plus y minus y1 squared equals r squared. Right, this looks nothing like that, right? Because we have this like this, 2x plus 1 over there, and this kind of minus 4y plus 4. So basically, I'm going to show you a method now for basically turning this equation here into that one over there. So what you can basically do is, if you look kind of closely, you'll notice that we kind of have two trinomials, right? We have this one over here and this one over here. See that? So you can basically split these up. And what you can basically do is you can just factor each of them. Now, luckily I can tell you in advance, for this one you don't need to complete the square. So for this one, you can kind of just do it, quote unquote, in your head, but there might be some where you do need to use this completing the square method. Okay, so again, we know this trinomial here, it's going to look something like this, right? So what number multiplies to positive 1 and adds up to negative 2? Well, it would be negative 1 and negative 1, right? Negative 1 times negative 1 is positive 1. Negative 1 plus negative 1 is negative 2. So we have minus 1, minus 1. Let's look over here on the right side now. So again, we have positive 4 on the right here and negative 4 in the middle there. So we have to think about what number multiplies to positive 4, what two numbers multiply to positive 4 and add up to negative 4. Well, again, if you think about it, it would be negative 2, right? So now what we have is we have this kind of big equation, right? We have x minus 1 times x minus 1 plus, right, we bring this plus down, y minus 2 times y minus 2 equals 25. So now again, if you remember, we can actually combine this into x minus 1 squared plus y minus 2 squared equals 25. And now you should notice that this equation here looks a lot more like this one up here. If you remember from last lesson, we can see now that our center is going to be 1, 2. Remember, it ends up being the opposite of what we have over here. So we can check that off. We see that. And the radius is going to be 5 because remember, our radius is r squared. So this 25 is really r squared. So if we do 25 equals r squared, the square root of both sides, our radius is going to be 5, right? So we've seen that's true as well. So next you can just work on these problems down here. Just keep in mind, you might have to, complete the square for some of them. You might have to use this method we talked about over here, but not necessarily. If you can just kind of factor it, quote unquote, in your head, that's fine too. You just kind of have to check whether you need to complete the square or not. All right, well, that is actually the last lesson for this year. So congrats on finishing the course, and I hope you all have a wonderful summer.